Hey students, this is a video. It's an example on finding the center of mass of a thin plate of uniform density. Okay, so we've got a thin metal plate and it's bounded by two functions, f of x and g of x. And I have these center of mass formulas simplified. So if you have your region bounded by f of x and g of x, if you look on my discussion board, I show you the steps, but this is how the formula is simplified. So what we're going to be doing is we're going to be doing an example of finding the center of mass. Okay, so what they want us to do is find the center of mass of a thin metal plate with uniform density. Now density means basically the amount of matter in a certain volume. Okay, so uniform density just means that it's smooth. There aren't areas that are more dense or less dense. Okay, and we want to find the center of mass of a thin metal plate with uniform density between the curve y equals 7 over x and the x-axis from x equals 2 to x equals 4. Okay? Alright, so how do we do this? Well, if you're doing the discussion board, I kind of write out the steps, but I figured it was good for me to make a video as well. So you're going to be using these simplified center of mass formulas. And in order to use these, you've got your x center of mass and your y center of mass. Now looking at these formulas, we're going to need an f of x and also a g of x. Okay, and f of x is going to be the function that's up higher on the graph, up here, and then g of x is going to be the lower function. Okay, so since this metal plate is between the curve y equals 7 over x and the x-axis, that means that 7 over x is actually going to be our f of x, because that's above the x-axis. And then for the x-axis, remember that the x-axis is just the same as the line y equals 0. Okay? So the x-axis is actually going to be our g of x. So that's going to be g of x equals 0. That's really the same as the line y equals 0, which is a horizontal line. Okay, so if you look at this graph here, up here, this curve on the top, that's going to be our f of x. And then on the bottom, we have our g of x. Okay, so here f of x is going to be 7 over x. And then g of x is actually just a horizontal line, y equals 0. So that's just the same as g of x equals 0. Okay, so now that we know what our f of x and our g of x are, we can go ahead and plug them into the formulas. So let's start with the x center of mass. So the x center of mass is the integral from a to b of x times f of x minus g of x dx all over the integral from a to b of f of x minus g of x dx. So there's a lot going on here. But since we know our f of x and g of x, all we really need is the a and the b. And that's going to be starting, for this problem, we're starting at x equals 2 and we're ending at x equals 4. Okay, so here x equals 2 is going to be our a. And then x equals 4 is actually b. Okay, so looking at these formulas, let me make this a little bit bigger. Looking at these center of mass formulas, which have been simplified, we can just plug everything in. Okay, so what we got here is for our x center of mass, we have the integral from a to b. Okay, so in the numerator we have the integral from 2 to 4 of x times f of x minus g of x. But we said our f of x in this problem is 7 over x, and our g of x is 0. Okay? And then, so that's going to be the integral from 2 to 4 of x times 7 over x minus 0 dx. That's the numerator of our x center of mass. And then our denominator is going to be the integral from 2 to 4. The integral from 2 to 4 of f of x minus g of x dx. So that's going to be actually 7 over x minus 0 dx. Okay, so what we're focusing on there right now is we're doing the x center of mass. So that's going to be the x coordinate of our center of mass. And by the way, this isn't a physics class, but the center of mass basically means where the middle is in terms of all of the matter that's spread out there. So here in this picture, the center of mass is going to be somewhere around there, but we're figuring out exactly where it is. And that's an important thing to do in physics and engineering. Okay, so we're working on the x center of mass right now. Okay, so that's what we're doing here. This is our x center of mass. So that's written x cm. Okay, and we can actually simplify this a bit. So for our numerator, any number minus 0 is just a number. So that actually simplifies to the integral from 2 to 4 of x times 7 over x dx. And those x's are just going to cancel out. Okay? So in the numerator, the x just cancels out with the one in the denominator there. And then on the bottom, we've just got the integral from 2 to 4 of 7 over x dx. Okay, and because 7 is a constant, we can factor out the 7 on the top and also factor out the 7 on the bottom. So I'm going to go ahead and bring the 7's outside of each integral. Okay, so what is that going to give me? Well, we're going to have 7 times the integral from 2 to 4 dx on the top. And then on the bottom, we have 7 times the integral from 2 to 4 of 1 over x dx. Okay, so now on the top and the bottom, the 7's are going to cancel out. Okay, and then we can go ahead and do this integral on the top. So the integral of dx is actually just going to be x. Okay, so on the top we have x evaluated from 2 to 4. And then on the bottom, remember that the integral of 1 over x is actually natural log of absolute value of x. So this one's natural log of absolute value of x. And that is also going to be evaluated from 2 to 4. Okay, so we're just working on the x center of mass first here. Okay, so now we can plug in these numbers. So on the top, remember you plug in the top number first and then you subtract the function evaluated at the bottom number. So we're going to have 4 minus 2 on the top. And then on the bottom, we're going to have ln of absolute value of 4 minus ln of absolute value of 2. Okay, and remember absolute value basically just makes a number positive, but if it's already positive, you don't need to write the absolute value. Okay, so since 4 and 2 are already positive numbers, we don't need the absolute value here. So I'm just going to get rid of it. Okay, so we really just have ln of 4 minus ln of 2 on the bottom. Okay, and then we can simplify this a little bit. So on the top we have 4 minus 2 is 2, and then on the bottom we have ln of 4 minus ln of 2. Now there's a couple ways you could simplify this. One way would be, if you remember, if you're subtracting outside the logarithm, that's the same as dividing inside the logarithm. So this is actually going to be the same as ln of 4 over 2. Okay? And then 4 divided by 2 is 2. So we actually get 2 over ln of 2. Okay, and of course you can type this into a calculator if you want to get an exact answer. This is the exact answer. Okay, so this is our x center of mass, and this is exact. But if you want to get a decimal approximation, you can type it into a calculator. Okay, so this is our x center of mass, and this is the exact answer. And then if you want to use whatever calculator you have, even just the one that comes with your computer, you can do 2 divided by ln of 2. Just go in scientific mode, and then you can do ln of 2 first. So 2 press ln. That's 0.69314, or 0.69315. Okay, so this is 2 divided by 0.69315, approximately. And then you can just go ahead and do that on your calculator. So 2 divided by 0.69315 gives us 2.86, or I'm sorry, 2.89. Okay, so our x center of mass is approximately 2.89. Okay, and of course we still need to find the center of mass on the y-axis. So to do that, we're going to be using these other formulas here. So since we have the x center of mass now, let me move this. Let me move these formulas, or now I'll just copy them down. Okay, so let's work on the y center of mass now. So the formula for y center of mass, YCM, is a little bit different. So it's right here. It's actually going to be the integral from a to b of f squared of x minus g squared of x dx. Now the squared just means you square whatever function you started with. So remember that in this problem, our f of x was 7 over x and our g of x was 0. So in our numerator here, we're going to have the integral from a to b. So that's going to be the integral from 2 to 4. The integral from 2 to 4 of f of x squared. So that's going to be 7 over x squared minus g of x squared. So that's going to be minus 0 squared dx. Okay, so that right there is our numerator. Integral from a to b of f squared of x minus g squared of x dx. And then in our denominator, we have a 2 times the integral from a to b of f of x minus g of x dx. So that's going to be the integral. It's going to be 2 times the integral from 2 to 4 of f of x minus g of x. So that's going to be 7 over x minus 0, okay, dx. So the numerator for this one is different, but the denominator is almost the same as the x center of mass. The only difference is for the y center of mass in the denominator, you actually end up with a 2 there. But it's still going to be the same integral that we did for the x center of mass for our denominator. we just multiply by 2. Okay? So now we've got our set up for our y center of mass. Now how do you square a fraction like this? You can actually just go ahead and distribute the square to the top and the bottom. So on the top, we're going to have 7 squared is 49. Okay, and then on the bottom, we're going to have x squared. Okay, so in our numerator, we have the integral from 2 to 4 of 49 over x squared, and then minus 0 squared is, well, 0 squared is 0, so we don't need that, so we're just going to have dx. And then in our denominator, we have 2 times the integral from 2 to 4 of 7 over x dx. Okay, and just like in the last part of the problem, we can factor out these constants. So we can factor out a 49 and on the top, and we can also factor out a 7 on the bottom. So if we bring out that 49 and we also bring out this 7, well, we're going to have 49 times the integral of 1 over x squared dx all over 2 times 7 is 14 times the integral of 1 over x dx. And both of those integrals are from 2 to 4. So with 49 and 14, the only common factor is going to be 7. So I can actually divide the top and the bottom by 7. Okay, and then beyond that, all we have to do is integrate this function and integrate that function on the bottom. Okay? So 49 divided by 7 is 7, and then 14 divided by 7 is 2. So we have 7 halves. And then how do you integrate 1 over x squared? Well, remember that 1 over x squared is actually the same as x to the negative 2 power. Okay, so the integral of 1 over x squared dx is the same as the integral of x to the negative 2 dx. Okay, so there you just use the power rule. Okay, so you add 1 to the exponent and then you divide by the new exponent. So that's actually just going to give you x to the negative 1 divided by the new exponent, which is negative 1. And then if we move our negative exponent back to the denominator, we're actually just going to end up with negative 1 over x. Okay? And of course, if it were an indefinite integral, we would write negative 1 over x plus c. But here, because this is a definite integral where we're going to plug in numbers, we just write negative 1 over x. Okay, so this integral in the numerator is actually going to be negative 1 over x. And that's evaluated from 2 to 4. And then in the denominator, we already did this integral. The integral of 1 over x is actually natural log of absolute value of x. So in our denominator, we have that again. Okay? And then now all we have to do is plug in the numbers. Okay, so in the numerator, plugging in 4 on the top, and then subtracting the function evaluated at 2. And we can also just bring this minus out front. Alright, so if I bring this minus out front, we're going to have negative 7 halves. And then in the numerator, we're going to have, plugging in the top number first, we get 1 over 4. and then we subtract the function evaluated at the bottom number. So that's going to be minus 1 over 2. Okay, so that's going to be 1/4 minus 1/2 on the top. And then on the bottom, we have ln of 4 minus ln of 2. And technically, we already did the bottom integral earlier. So we already know that that's going to be ln of 2 on the bottom. Okay, but anyway, we can simplify this a little bit. So for the 1/4 minus 1/2, we need to build these to a common denominator. So I'm going to multiply the 1/2 by what I'm missing, which is 2. So I'll multiply the top and the bottom by 2. Okay, so we're going to get negative 7/2 times, well, on the top we have 1/4 minus 2/4. And then on the bottom, once again, subtracting outside of a logarithm is the same as dividing inside the logarithm. So on the bottom, once again, we're going to get ln of 4 over 2. Okay, so on the top we have 1/4 minus 2/4 is going to give us negative 1/4. Okay, so we have negative 7/2 times negative 1/4 on the top. And then on the bottom, once again, just like with the x center of mass, we have ln of 2. Okay, and then remember, negative 1/4 up here is the same as negative 4 on the bottom. Okay, so these minuses are going to cancel out. So I can cross out the minuses. And then in the numerator, we're going to have 7. And then in the denominator, if I go ahead and move this 1/4 down here, we're going to have 4 times 2. So we're going to have 4 times 2 ln of 2 in the denominator. And then 4 times 2 is actually 8. Okay, so we have 7 over 8 ln of 2. And that's generally how you would want to leave your exact answer for your y center of mass. So this is our exact answer. Now on the discussion board problem, you could also use the power rule, and you could bring this exponent up here. But for this example that I'm doing here, you would get ln of 2 to the 8. So if you use the power rule for logarithms, 2 to the 8 is kind of a big number. So if I do 2 to the 8, that's actually 256. So you could also you could do that if you wanted. So so down here we could have 7 over ln of 2 to the 8, which is actually 7 over ln of 256. So that would be another way of writing your exact answer. And that's just taking advantage of the fact that if you have something multiplied times a logarithm, you can actually bring that into the exponent. So that's what we did there. We brought the 8 into the exponent. So we got ln of 2 to the 8 in the denominator. And then 2 to the 8 turns out to be 256 if you type it into a calculator or write it out. Okay? So this answer right here would also be fine. Okay. So either of those are good for your exact answer, for your y center of mass. And then for your decimal approximation, it might be easier to use this form to type it into your calculator. So first we're going to do ln of 256. Okay, so 256, and then I press ln. So that gives me 5.5452. 5.5452. 5.5452. And that's our ln of 256. And then if we do 7 divided by 5.5452, that will give us what we need. So 7 divided by 5.5452. That gives us 1.26, which is, I believe, what they got on my math lab. Yeah, 1.26. So they round them. They round these to 2 decimal places, so that's why I'm doing that. Okay, so this is approximately 1.26. And that's our y center of mass. Okay, and then for our final answer, remember the center of mass is actually a point. So we actually figured out exactly what that center of mass is. So for our final answer, we're going to be writing it as an ordered pair. So that's going to be x center of mass, comma, y center of mass. So xcm, comma, ycm. Or in some books, they actually call it x bar, comma, y bar. Okay, but those both mean the same thing. And so we said that our x center of mass was approximately 2.89, or 2 over ln of 2. Okay, so we have x center of mass is 2 over ln of 2, and then our y center of mass, as an exact answer, was 7 over ln of 256, or alternately you could just leave it as 7 over 8 ln of 2. Okay, so this right here is our exact answer. And then for our approximation, that's going to be approximately equal to 2.89, comma, we said 1.26. Okay, and that right there is the decimal approximation. And I rounded that to 2 decimal places, just like they do on my math lab. Okay, so I hope this video was helpful, and thank you for watching.